Hi, this is Mark Schuyler, and today we're going to go over three vital formulas for the SAT and the ACT. You need to know slope, you need to know midpoint, and distance. Well, I've put a graph here that has allowed me to put in 2 points and label them clearly into the Cartesian plane. By the way, I love that word, the Cartesian plane. Let's take a look at that. I'm going to spell that out. Most people know this as the XY coordinate grid, but it has another name. It's called the Cartesian grid or the Cartesian plane. And I prefer this name because this name honors the person who actually invented the XY coordinate grid system. A gentleman who was a philosopher and a scientist and a mathematician. You've probably heard of him. His name is René Descartes. And he's really the dude who figured out how to connect geometry with algebra. Before that, they were two very separate mathematical areas, and he has figured out that there's a way to graph every algebra statement, and that there is a way to merge these two heretofore disparate mathematical spheres into one. Wow, I sound like I know what I'm talking about. All right, let's keep going. So I want to make sure that you know one other thing before we begin. Not only that René Descartes, there's where we get Cartesian plane, invented this, but he numbered the grid system in an interesting way. And I want to make sure that there's no confusion about the numbering of the grid. We usually use quadrant 1 a great deal, and that's not a surprise. Everything in quadrant 1, as my 2 points here, are positive, positive, but he did number the other quadrants in counterclockwise fashion. So you need to know that this quadrant is 2. The one down here that's negative, negative is 3, and here is quadrant 4. It's a very common mistake on the test that people would go clockwise, the way a clock turns, but the numbering of the coordinate grid system, the Cartesian system, is counterclockwise. All right, so now that you know that, let's take a look at these points. So today's goal is to cover these three formulas in rapid succession. Slope formula. Well, it can be written in a variety of ways, right? One way that we know we can write it is rise over run. That's really simple. That's the change in the y. I'll use the delta symbol, which in math and chemistry and physics means change. The change in y over the change in x, how much the point is climbing, or I should say the line is climbing from one point to another. For example, we could look at the y-coordinates here. We could look at this y-coordinate and this y-coordinate, and we could say it's a rise of 8. I'll write that over here. Over a run, well, the run is when we're looking at the x values. It's running from 4 to 10, so it's running 6. 8 over 6, that reduces to 4 over 3. The slope of my purple line here is, and slope is usually m, right? We give it the variable m, is 4/3. Life is good. And we would slot that in to the equation of a line. Y equals mx plus b. I'm going to drop in the 4/3 for m. Here's the x, here's the b. The b is the y-intercept, you'll recall, and this whole thing is called the equation of a line. Sometimes it's called the slope-intercept form. Now, there is a more thorough and more detailed way of writing the slope formula than rise over run or the change in y over the change in x. If you've taken geometry any time in the last year, I'm sure you recall the slope formula. It's pretty memorable. I'll write it out. The full detailed slope formula is m equals y2 minus y1 over x2 minus x1. And I think using the more detailed formula, even though it might be a little bit slower, is a better idea, especially if you have some points that are in other quadrants besides our really easy quadrant 1. When you start having points that are located in quadrants 2, 3, 4, and some negative signs are creeping in, it's really important to label your points. In other words, I'd label this one x1 and this one y1. But down here, I would label this point x2 and y2. And then carefully substitute them in to our y2 minus y1 over x2 minus x1. But that's a quick way to get slope, and if we did it that way, it would work out to the 4/3 that we saw earlier. But the full formula, I'm advocating you use that if the points are not so easy with a positively sloping line, with the points in quadrant 1. If the points show up in these other quadrants and it might be a negative sloping line, these are all situations where you would want to use the full slope formula. Now, midpoint is super easy. A lot of my students say to me, Mark, I totally forgot the midpoint formula. Don't even think about it as a formula, really. All you need to do is average the two x-coordinates of the 2 points that we have. I'm going to make these points stand out a little bit more. I'm going to put them in this funky radioactive green. And if you average 4 and 10, what do you get? Well, we know, especially if you watched my mean average video, that you add them up, divide by 2 in this case. We have 2 numbers, so 14 divided by 2 is 7. So the midpoint, this point that would be somewhere right in the exact middle, actually, it should be at 7. Okay, that's its x value. But let's average the y values. Average of 10 plus 2 divided by 2, 12 divided by 2 is 6. We would get the point 7, 6. That is the exact midpoint. Now, if you want to look and see what the formula looks like if it's written as an algebra statement, I'm happy to show it to you. It's what you might expect. You take your x1, add it to your x2, divide it by 2, comma, y1 plus y2, all that over 2. See, this is when you're averaging your x's, averaging your y's, and you put it together inside of a pair of parentheses, a comma in between your x value for the midpoint and your y value for the midpoint. That's the algebra, but honestly, just think of midpoint as averaging the 2 x's and then averaging the 2 y's. All right, distance. Now, distance is a whole different kettle of fish from slope and midpoint. The formula for the distance formula, where you're calculating the distance between, say, this point and that point, it's pretty complicated and we need to memorize it. You will want to practice it, write it out, have people test you on it. Let me go to the next slide so we can take a better look at this. Okay, so as you can see, I've cleaned up the page for us, and here's the distance formula that we need to have completely memorized. I don't think it's as hard as memorizing the quadratic formula, so if you've done that, this should be easy. The distance formula is all happening under a giant square root, and it's the quantity x minus x squared plus the quantity y minus y squared. You don't need to remember x1s and x2s and y1s and y2s. It doesn't matter what order you put the x values in. So, for example, we can put in the 10 over here, this x value, and we can put in the 4, the other x value, in this order, or we could put them in like this. The reason it doesn't matter, even though you're getting 2 different answers, one is 6 and the other is -6, is we end up squaring those. And so -6 equals the same thing that +6 does, namely 36. Then, again, without too much concern for order, we put in the 2 y values, which are 10 and 2. So we have 10 minus 2. And we know that's going to work out to the same thing as 2 minus 10 squared will work out to. It's going to be either 8 or -8, but squared, they're both 64. If you add together the 36 and the 64, you get a nice round 100. And it's all happening under that square root sign. So it's a nice 10, an even 10. That's the distance. And I think, as I've said, don't want to belabor the point, but it is a feat of memorization and really not that difficult. We're not talking rocket science. Might as well get something out of the hard work that we did. The distance from here all the way to there is exactly 10 units, from 4,2 to 10,10, using the distance formula. So we've gone through slope, we've gone through midpoint and distance. I hope you see they're all somewhat related. Basically, we're talking about 2 points in the Cartesian plane. What can we do with these 2 points? We can easily find their slope, their midpoint, and their distance between them. Hope that was helpful, and I will see you for the next video.